Here are some common functions. A linear function is a function of the form f of x equals mx plus b, where m and b are constants. These are lines. If m is positive, the line points upward. If m is negative, the line points downward. B is the y-intercept. It's the value on the y-axis where the graph crosses. Quadratics are functions of the form ax squared plus bx plus c, where a is non-zero. These are parabolas. If a is positive, the parabola opens upward and is called concave up. If a is negative, the parabola opens downward, and the parabola is called concave down. Cubics have the form ax cubed plus bx squared plus cx plus d, where a is non-zero. If a is positive, then cubics are going to start in the lower left and end in the upper right. If a is negative, the cubic starts in the upper left and ends in the bottom right. Cubics tend to have two bumps. A degree n polynomial is a polynomial of the form a to the n plus bx to the n minus 1, etc., where a, b, r, and s are constants. An nth degree polynomial will typically have n minus 1 bumps. If a is positive, then it'll end in the top right corner. If a is negative, it'll end in the bottom right corner. Exponential function is a function of the form a b to the x, where b is greater than 0 but not equal to 1. If b is greater than 1, then what ends up happening is we have a function that, typically assuming that a is greater than 0, starts out lower left and gets larger. And of course, if b is between 0 and 1, then it'll start quite high and be asymptotic to 0. Logarithm is a function of the form log base b of x plus c, where b and c are constants. If our b is greater than 1, we have sort of a graph that looks like the blue guy. If b is between 0 and 1, then we have a graph that looks like the pink one. A rational function is a quotient of two polynomials. So for example, something like y equals 1 over x, or y equals x over x minus 1, where q is equal to 0, we're going to end up having an asymptote. Absolute value functions have a V shape. The vertex, or the lowest point, is the point of the V. Square root function sort of looks like a square root shape. Its domain is non-negative real numbers. Another type of function we might want to consider are piecewise functions. So sometimes we need more than a single formula to specify a function algebraically. In this example, we use the first piece when x is between -4 and -2. That first piece is f of x equals -1. We use the second piece, the 5x over 3, when x is between -2 and 2. We use the third piece, the negative x minus 3 squared plus 3 divided by 3, if x is between 2 and 4. What happens at the endpoints of these intervals depends on where when x is equal to the certain values. So for example, we use the first piece when x is equal to -4 and when it's equal to -2 and all the values in between. The second piece has strict inequalities, so we don't use -2 or +2. Here, if we're looking at f of 0, 0 is between -2 and +2, so we use the second piece, the 5x over 3. If we're looking at f of -3, -3 is between -4 and -2, and so f of -3 uses the first piece, -1. If we're looking at f of 4, 4 is between 2 and 4 inclusive, so we use the third piece, negative of x minus 3 squared plus 3 over 3, or negative 4 minus 3 squared plus 3 divided by 3, or 2/3.